Okay, guys, so today we're going to be learning two new formulas. These are going to be on your orange sheet, and these are the ones that we have not worked with yet. They're called the sum and the difference formulas. And what they say for sine of any angle plus another angle, it's going to be equal to sine A cosine B plus cosine A sine B. If we're doing the difference for sine, look at the formula. Sine A cosine B minus cosine A sine B. Do you see how the pattern is the same for both of these, for the sum and the difference? It's the same pattern. But what is true of the sign in the middle? When it's plus here, what is it here? It's addition. And if it's subtraction here, then it's subtraction. One thing you cannot do that sometimes people think is okay is you can't just distribute sine through the angle. The formula for this is right here. We have to do the sine of the first angle plus the cosine of the second, and then plus cosine of the first, sine of the second. The pattern for cosine goes like this. It goes cosine A cosine B minus sine A sine B. And then if we have subtraction, it goes cosine A cosine B plus sine A sine B. Guys, it's a lot to remember on this, but it's not something you're going to have to memorize this year. But as you work through more and more problems, you're actually going to start memorizing just because you're going to use it so much. But I want you to look at the pattern. So the pattern for sine goes sine, cosine, cosine, sine. Sine, cosine, cosine, sine. And same in the middle. You see what I mean by same in the middle? Okay. For cosine, it goes co, sine, sine. So when I see cosine, I just think cocoa, because I know that's going to be the one that goes cosine. Cocoa is cosine, cosine. And notice the sign in the middle. See how there's an O here, opposite? So if this is plus, this is minus. If this is minus, this is plus. All right. I want to go back to the notes now, and we're going to apply some of these. In order to be able to do these problems, we need to identify the angles for which we know the exact ratios. So in this first quadrant on the unit circle, we have all these angles here in the first quadrant. We know that our first angle we come to is 30 degrees. What's 30 degrees in radians? Pi over 6. What is the sine of pi over 6? 1/2. What is the cosine of pi over 6? And what is the tangent of pi over 6? Good. Radical 3 over 3. Great. What's the next angle we come to? A special angle? 45 degrees. What is that in radians? And what's the sine of pi over 4? Good. What's the cosine of pi over 4? And what is the tangent of pi over 4? 1. What's the next one we come to? 60 degrees, pi over 3. What's the sine of pi over 3? What's the cosine of pi over 3? And what is the tangent of pi over 3? Very good. We will be using all of these angles. We already listed the angles in the first quadrant, so let's change this to quadrant 2 and 3. In quadrant 2, the first angle that I would come to as I move around the unit circle, it goes 30, 45, 60, 90. This one would be 120. What is 120 in radians? 2 pi over 3, right? The next angle I come to in quadrant 2 is 135 degrees. What's another name for it in radians? Good. And then I come to 150 degrees in radians. What is it? Good. And we'll go ahead. That's in quadrant 2, our special angles. Quadrant 3, our special angles. The first one we come to is 210. What is that one going to be? Good. Then we come to 225. What's that going to be? Good. And then we come to 240. And what's that going to be? Good job. Okay, and then in quadrant 4, working our way there. Let's just make this quadrant 4. We'll just get it all done right here. So the next angle after 270, I go over here. That's going to be what? How many degrees right there, guys? 300. So 300 degrees. The reference angle is 60, so it has to be something times pi over 3. What is it? 5 pi over 3. Then we come to 315. Do you know that one? And then we come to 330. That's a 30-degree reference, which is pi over 6. So what is it? 11 pi over 6. Now, the whole reason we took all that time doing that is these are the angles that we're going to be using when we're doing these problems that we're going to look at next. These are the only angles that we can evaluate exactly without using a calculator. So these are the angles that we're going to be restricted to. Here's for quadrant 1, quadrant 2, quadrant 3, quadrant 4. And down here, we're just going to put a couple of the quadrantals just in case we need them. 0, of course, is 0. 90 degrees is what in radians? Pi over 2. 180 degrees is just what? Pi. 270 degrees is? Okay, so if we need them, we will also be using those. All right, so how in the world does this even help us? Let's come over here and look. We want to find the exact value of the sine of 75 degrees. Exact. That means not a decimal. I cannot just put this into my calculator. I want to find the exact answer. So what I have to do is I have to think of two angles from our list that will either add or subtract to give me 75. Let's go back to our list of angles. Because 75 is acute, I probably want to stick with my quadrant 1 angles. What are the angles that would add or subtract to give me 75 degrees? Right. So this is going to be rewritten as the sine of 30 degrees plus 45 degrees. That's another way to write this. Isn't it true that 30 plus 45 is 75? So now I'm going to look at my formula for the sine of A plus B. Here's how the pattern goes. Sine of my first angle. In this case, A equals 30 degrees. B equals 45 degrees. For this first problem, I'm going to write out the formula. Here's the formula. Sine of A plus B is equal to sine A cosine B plus cosine A sine B. That's the formula that I have to use. Now I'm just going to plug in. Here's my A, here's my B. So to find the sine of 75 degrees exactly, it's going to be the sine of 30 degrees. So I'm going to have to do the sine of 30 degrees, cosine of 45 degrees, plus cosine 30 degrees times the sine of 45 degrees. Now, what is the sine of 30 degrees? 1/2 times, what is the cosine of 45 degrees? Plus, what is the cosine of 30 degrees? Times, what is the sine of 45 degrees? Okay? And now I'm just going to simplify. 1/2 times radical 2 over 2 is radical 2 over 4 plus radical 3 times radical 2 is radical 6, and 2 times 2 is 4. Because I have a common denominator, I can rewrite this as radical 2 plus radical 6 all divided by 4. That is the exact answer for the sine of 75 degrees. Now, I'm going to show you how I can check that on my calculator. Our goal is to be able to find these without having to use our calculator, but we want to be able to check on here. So what I'm going to do is I'm going to go to my mode and I'm going to put it in degrees. And I'm going to find the sine of 75 degrees. There's what it is. The answer that we got should be the same. Let's check it out. Parentheses, radical 2 plus radical 6, parentheses. What do I want that whole thing to get divided by? And so now to check my answer, and it's exactly the same. If you're taking a quiz or a test and you give me 0.9659258263, that is not an exact answer. Why not? Does this stop right here at the 3? No, it goes on forever because these are irrational. So therefore, that is not an exact answer. Only this is going to be the exact answer. All right, does that make sense? Okay. We're not going to do every single one of these, but I am going to do one more with, I'll do a couple more, but let's talk about tangent of 255. I don't know the tangent of 255 because it's not on our list of our special values. 255 isn't. So you've got to think of two angles that are in our list. All right, so 255, which quadrant would that be in? Quadrant 3. So one of our angles we're going to use is probably going to be in quadrant 3. Not always, but can you guys find any combination of angles? Drew? 225 plus 30. Let's see if that works. 225 plus 30. That gives us 255, doesn't it? Is that our only option? I was thinking of 210 plus what? That would work too, right? So it's not that there's only going to be one possibility here. Maybe we could even do, look here in quadrant 2. What if I add just these two together? What do I get? 255. So it doesn't matter what we choose. Yeah.
So it doesn't matter.
Because I just said it doesn't matter. Yeah, it's not going to matter which angles you choose as long as they add up to be 255. So like everybody in the class might come up with two different angles, but we'll all get the same answer. All right, let's look at our formula now for tangent. Is this a sum or is this a just difference? Sum. So I'm looking at the sum formula. Now next year when you're in pre-calc, they're going to make you memorize these, but for now we're going to give them to you. All right, so here's our formula. It's going to go tan A plus tan B over 1 minus tan A, tan B. Here's A, here's B. All right, so we're going to plug this in now. So it's going to be the tangent of 225 plus tangent of 30 over 1 minus the tangent of 225 times the tangent of 30. All right, tangent of 225, it's a 45-degree reference angle. What is the tangent of 225? 1. That's in the third quadrant, right? So it's going to be a positive. So it's 1 plus, what's the tangent of 30? radical 3 over 3. Now I have 1 minus tangent of 225 we just did. That was 1, right? So it doesn't matter. I don't really have to write it again. And then times the tangent of 30. And that is radical 3 over 3 again. Whew. We have a difficult problem here because it's a complex fraction. Do you guys remember how to clean this up so that I don't have a fraction within a fraction? What's the denominator that's common to both? So I'm going to multiply the top by 3 and the bottom by 3. When I multiply by 3 over 3, what is 3 divided by 3? So I'm not changing the value if I multiply by 1, am I? It's still the same value. So we're going to do 3 times 1 is 3 plus, what is 3 radical 3 divided by 3? Just radical 3 over, do this now, 3 times 1 is 3 minus, what are we going to have? That's going to be radical 3, right? Okay, we're making progress. However, they're not going to let you leave it like this, and why is that? Because we have what? Radical in the denominator. So to get rid of that, I really need more room. You know, and also, guys, this problem might have been easier if we would have chosen some different angles, but it's okay. We might as well stick with it for now. We didn't know that, so we just got to go with it. I will give you a hint, though. You want to try to not have like radical 3 over 3 if you can avoid it, okay? So what would it have been easier to use? The tangent of what instead of the 45 would have been easier, but we would have had to have used, could we use 60 here? If we had used 60, I don't think 60 would have worked, would it? Yeah, I don't think we had any other option. All right, let's just keep going. So what we have to do is multiply by the conjugate of the denominator. So I wrote that too big. Let me write it again a little smaller. So I'm going to have to multiply by the conjugate here, which is 3 plus radical 3 on bottom. If I do that on the bottom, I have to do it on the top too. I'm just multiplying by the conjugate of the denominator to get rid of this radical. Whenever I have two terms, that's what I do. So let's multiply out the top. 3 times 3 is 9. The outers gives us plus 3 radical 3. The inners gives us plus 3 radical 3. And the last times the last gives us what? Plus 3. Good. In the denominator, we get 3 times 3 is 9. The outers give us positive 3 radical 3. The inners give us minus 3 radical 3. And what did the last times the last give us? Minus 3, right? Okay, so what's the top going to simplify to? Good. 12 plus 6 radical 3. What is the bottom going to simplify to? 6. So now it's going to be 12 over 6 plus 6 radical 3 over 6. These can be split apart now since we have a single value. We have to have a single value in the bottom. What's our final answer here then? Not 12 plus, 2 plus radical 3. That's the answer. That's about as tough as you're going to get. Tangent is the hardest one to use. Sine and cosine are going to be what we're focusing on more. So let's do one more problem. I want to do the cosine problem. Okay, guys. Why is this problem a little more difficult? There's two reasons, actually. It's in radians and also it's negative. All right, but that's okay. We can deal with all that. If I have radians, I always change it into degrees. It's a lot easier for us to think in degrees than radians. Next year, they might say, oh, we don't want you doing it that way, but you can do it off to the side if you need to, and then just turn it back into radians. I think it just makes things go a lot faster. So what's another name for pi in degrees? So I have 180 divided by 12. What is 18 divided by 12? 1 with how many left over? 6. What's 60 divided by 12? 5. Guys, this is something you want to know. It's going to happen all the time. 180 divided by 12 is 15. If you can remember that, it's going to make things go a lot faster. 180 divided by 12 is 15. Now what do I need to multiply 15 by? 7. And so that's going to give me 105. So my problem is really the cosine of negative 105 degrees. Now, we have lots of options. Negative 105. Can anybody think of two numbers from our list, and they can be positive or negative, that will give us 105? Very good. So I'm going to think of this as the cosine of negative 45 plus negative 60. There are other options, but this is going to be fine. How does cosine start? Does it go cosine sine or coco? Coco. So this is going to be cosine of negative 45, cosine of negative 60. And then is it the same or the opposite of this middle sign? Opposite. Look, we're already memorizing this. Then we have the sine of negative 45 times the sine of negative 60. We're not going to do this one anyway, so it's okay if you run over there. All right, cosine of negative 45. That's just in the fourth quadrant. Right there, fourth quadrant. What's the cosine of negative 45? So we're going to have radical 2 over 2 times the cosine of negative 60. 1/2, very good. Cosine is positive in that fourth quadrant. Now we have subtraction, and now we have sine. Is sine going to be positive or negative in this quadrant? Negative. So what is the sine of negative 45? Great. Times, and what's the sine of negative 60? Very good. All right, so now we're going to have radical 2 over 4, and we're going to have minus a negative times a negative. Is this going to be a plus or a minus in between these two? So it's going to be minus, and then what's this going to be? Okay, so then we're going to end up with radical 2 minus radical 6 all over 4. And I'm just going to do a quick check just to remind you of how you can check these. I'm going to change my mode to radians. I'm going to go back to the original problem. I'm going to do the cosine of negative 7 pi divided by 12. And I'm going to compare that with parentheses radical 2 minus, oops, got to get out of that radical, minus radical 6, all of that divided by 4. I can't see that. See how they're the same. So we know we did it correctly. All right, guys, so this is some challenging stuff here at the end of the year, but this is going to help you so much. Excuse me. If you can get a handle on this now, next year is going to seem a lot easier to you. Okay? So you have a big ideas assignment. I only gave you 5 problems to do, just 5. But you have to do these on a separate sheet of paper because it's I don't want you just sitting there and guessing 3 times. That's not going to get you anywhere, okay? Do these on a separate sheet of paper.